Right. We talked about alkanes a little bit, and let's name these together. Okay? What's that? Don't look at your book. Try to figure it out yourself. Methane. Ethane. Propane. Butane. Pentane. Hexane. Heptane. Octane. Okay? And you can see that these are the boiling points. So remember I said yesterday that it was somewhere around here. I actually kind of included butane a little bit as a liquid at room temperature. And the reason I did that was because if you increase the pressure, for instance, if it's in a cylinder, it's going to be liquid butane because you're going to have high pressure. And if you increase the pressure, you're going to liquefy it. Okay, little lighters, they're under pressure. Okay, and I'm not sure it's pure butane either, by the way. It could be some pentane in there. You can see pentane would boil easily on some days in Cambodia, right? Okay, and this is hexane, heptane, and octane. So you can see that the temperatures in which it boils are certainly tied to the number of carbons. 1 carbon, 2 carbons, 3 carbons, 4 carbons, etc. Clear? Just wanted to point that out. Because yesterday I kind of put butane in the liquid state, and I think I said on the video that it was pressure dependent. Okay. If it's at 1 atmosphere, it's obviously going to boil at -5 degrees, but you know, clear? Okay. So now let's talk about, and I purposely erased them. Is there a formula for determining the number of hydrogens or the formula of a alkane? Is there a formula? What's the formula? Yeah, very good. Yeah, 2n plus 2, right? Right. You multiply the number of carbons by 2, right? If there's 3 carbons, that would be 6 hydrogens, and then add 2. So let me give you, how about 20 carbons? How many hydrogens?
42.
42, very good, okay. Now, difficult with some of the other ones because it depends on how many points of unsaturation. What's the point of unsaturation? What is that? It's like a double bond, triple bond. So it's a little bit more difficult to come up with the formula for an alkene if you have more than 1 point of saturation. Okay, so let's list and name the functional groups. Yes? Okay, so let's start, and they talk about it in the book, and they say alcohol. Okay, that's alcohol. Okay, I'm very dyslexic, so you're going to have to help me with spelling periodically. Okay, if I misspell a word. Okay, actually, I'm not very, I'm mildly, so just enough to screw up my spelling. So what's next? Give me another one. I have alcohol down. What else? All right, an alkene. All right, alkene. And what's an alkene? How do I write that?
A-L.
No, I understand how to spell it. Alkene or alkane. But how do I write it? How do I write, and how do I represent it? What is it? Yes, I go, right? Right? Double bonded carbon. Yes? I think that's the way actually it's done in the text, isn't it?
Yes.
Where are the functional groups? Yes. And what they do is, they do this. This is an alcohol with one bond there. So they're going to say that if I have an alkene group, functional group, then I have to make sure that it's there and all the bonds are available, okay? And you know, what kind of hybridization is it? sp3, sp2, sp? sp2, 1, 2, 3, and then you have a pi bond, okay? Remember, a carbon-to-carbon bond, there's got to be a sigma bond in there, got to be. And the hydrogen bonds, the bonds to the hydrogen are going to be sigma bonds. The pi bonds are the extra bonds between the carbons, correct? Okay, what else? Why don't we do this one while we're at it? What's that? Alkynes. Or just alkyne. What else? What else? Come on, guys.
Ether.
What is it?
Ether.
Ether. Okay, what does ether look like?
Or single bond with O. And then a bond with O.
Like this? Like that?
Have all prime.
What is it?
All prime. What is all prime?
The last R.
Yes. Yeah.
Oh, that just means it could be different. It may not be different. Okay? For instance, you can have this. Or you could have this. No, we won't. We'll just say it. This is ether. Ether. So you can have methyl ethyl ether, or ethyl methyl ether, okay? Or, so you just say the group. See, these are functional groups. An ethyl group. I'm sorry, a methyl group or an ethyl group, okay? A pentyl group, etc. A hexyl group. So you can have a dimethyl ether, where you have a methyl on each side. Okay? So we just talked about two additional functional groups. That's ether. We also have CH3 and C2H5. Those are the common ones. I don't think they go to any more than that, do they? Or do they have those? They don't have those? That's a little weird. Yeah, I want to put those down as groups. Okay, that's methyl, and that's ethyl. Okay, I want to put those down as groups, and we'll deal with those later. Okay, what else? What other groups do we have? Carboxyl. We did that yesterday, right? So we have carboxyl. Carboxyl. How do you spell carboxyl? That's a very important word to be able to spell, carboxyl. What are the endings of these words? How do you end them? What's the suffix that you're using? IC, ic. What about ethyl? Just ethyl, okay? Or methyl, and it's a little bit difficult to put into words, but when we talk about the nomenclature, we'll deal with that. What about ether? What is it for ether? The oxyalkane. Oxyalkane. Okay, where are we? Oxyalkane. Okay, and what else? Let's see. What else? Ketones are very important. Biologically, they're very important. Okay? Biologically, they're very important. Didn't they go over ketones last year? No? In biology?
We don't have biology.
Okay? So, that's a ketone. If you're not digesting carbohydrates correctly, or proteins in your fats and things in your blood, you can develop ketosis. You urinate substances with ketones in it. There's a very famous diet, which is kind of dangerous, I think, but people do it, and I did it too, but it's called the Atkins diet. And the whole concept of Atkins diet is to get your body into ketosis. Weird. But anyway, you're producing ketones, which can, I don't know, hurt your body. I think it has something to do with your kidneys. Not very helpful. What else? Give me another one. Give me another one. Oh, what's the ending of the ketones? What's the ending of the ketones? What is it? Anone, right? Anone. Anone. Where is it? Oh, this is, what is this? Ether, right? No. Ketone, sorry. We did ether.
Yes, a ketone.
This is ketone. And what is it? How do you spell it? Okay, anone. Okay, what else? What is it? I can't hear you. Give me a. Caitlin, what are we saying?
Aldehyde.
Oh, aldehyde. Yes, aldehyde. Similar in structure. I mean, it kind of looks like, you know, the carboxyl group. What's the aldehyde? What's the difference between the carboxyl group and the aldehyde? This is going to an R, by the way. Aldehyde. How do you spell aldehyde? A-L. What is it? D-E. H-I.
Oh, sorry, H-Y.
Why? Because you have to. Aldehyde. What else?
D-E.
D-E. And what does it look like? You have the R group, right?
Yes.
And then you have what? You can do this. You're going to have a carbon. You have a double bond O.
Single bond hydrogen.
Yeah. So it's kind of like an alcohol, but without the oxygen, the second oxygen, yeah? An aldehyde. What's probably the most common aldehyde when you think of aldehyde? Think of writing a form letter for business. Put the word form and aldehyde together, what do you get? Maybe you guys are way too young to remember this or to know this, I guess. Formaldehyde? You ever hear of formaldehyde? Okay, never mind. There's a good reason why you've never heard of formaldehyde. It's a good thing. It's kind of a little carcinogenic, in large amounts anyway. So what else? What else? Is that it? All right, can I erase some of this stuff? I just wanted to introduce you to them and look at some of the structures. Yes? Pretty cool? Yes? Yes?
Yes.
Okay. Okay, what else? Amide. Very, very important in a lot of ways, amides. We'll be looking at that when we look at medicinal chemistry. What's the structure of the amide?
Carbon.
Yeah, if I take the H off of aldehyde and I put on an amine group, right? Yes? What is the shape of this? What's the geometry of that? No. Trigonal pyramid, right? You have 2 electrons up here. If you isolate on that, right? Yes? Remember, high nitrogen has 3. Let's look at ammonia. Right? It's trigonal pyramid. Remember? You do that last year?
Yes.
Okay. So if you look at that side of it, you'll see that that's there, and that's kind of important because you have those electrons. That's like a nice bonding site for certain chemicals, radicals that'll come in there. Okay, cations. Okay, so this is called amide. Okay, yes, good. And what is the geometry around here? What's the geometry around there relative to that? You should be able to look at it, guys. Like that, 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 like that. You're missing a lot with the organic chemistry if you don't know your geometry. Trigonal planar, right? We're going to review. We're going to spend a lot of time reviewing molecular geometry and bonding. It's really the linchpin that holds everything together. If you don't know your bonding, it's going to be difficult. Yeah, it's going to be difficult to know things like intermolecular forces and why certain physical states exist for certain chemicals and certain things about physical properties. And then when you talk about thermochemistry, you will have to bring that into it to understand it relative to entropy and enthalpy. So the bonding, the molecular geometry is very important. All right. What else? What's another one? What's another one?
Amide.
We did amide. What is it? Amine. I want to say amino. What's one of the main where does the word amino acid get its name from? The amine group, right? Right?
Yes.
Cool? Yeah. Okay, so what do we have? We have N, right? And then that's the group. I guess you have two of these. What's amine look like? This is going to go to, kind of looks like this actually, where you have, this is going to be your R group. I hate to contradict these people, but it's going to kind of go like that. Yeah, there's a bond that forms here, then you're going to have those extra electrons there, even though it kind of like looks like this structurally. They kind of draw it like that, don't they? Yes? Yes? Don't they draw it like that? Which is a little misleading. Unless you say that the 2 spare electrons are on that side of it. Okay, so you're looking at it like this. So here's the pyramid, right? It's kind of like out like that, you could say, right? If you're going to draw it like that, then you're going to have to make sure that you understand the pyramid is coming out of the board, right? Instead of down, where this is on the other side of the board, right? Yes? Okay, where this is on this side of it. This is over here, and then these two are on the other side. So it depends on how you're drawing it. Yes? Okay. So that's the amine group. Yes? Very important. Nitrogen is pretty critical stuff. What else? Oh, the nitrile. Nitrile. How many bonds does nitrogen need? How many bonds does nitrogen need? 3 bonds. So you have this one. You have carbon, and then you have this nitrogen. Now don't forget, you have this spare electrons over there. And so this is on the end of the molecule, right? The nitrile group. So what happens, what do you think? Is this reactive, do you think, the nitrile group? The nitrile functional group, is it reactive? See, it's important. Why do we do molecular geometry at all? Why do we do it? Because it kind of shows you how things can be reactive. What's very available right there? Very available.
Nitrogen.
No. Dude, what is chemistry, the study of? Electron behavior, isn't it? Can't you reduce the definition of chemistry to simply the study of electron behavior? Really, can't you? It's just, you're just studying valence electrons. That's all you're doing. Aren't these valence electrons? Don't they just stick out there and say, you know, come and react with me, I want to play, you know, I'm outside, I want to play. Look at them, they're just sitting there, right? I mean, they're on the end. There's nothing around them, right?
Yes.
Amazing. If this is on the end of the molecule, what do you think? Pretty intense, don't you think? Yes? Okay. And then the last one that we're going to look at is going to be the benzene ring. It's actually a hexane ring, right? It's a hexane ring, but what happens is you have this alternating double bonds, like that, right? Now, each carbon needs how many bonds to function? 4 bonds, right? So you have a hydrogen coming from each, like that, right? Yes? Yes? Now, when you represent a benzene ring, you can do it in a couple of ways. You can just go like this. The benzene ring. Or more commonly, you can say go like that. Because they say that, what do these lines mean here?
Single bond.
No, it doesn't mean single bonds. It means that these double bonds resonate around. Okay? Because remember, these are pi, there's one pi bond there, there, and there, right? So you get these pi bonds kind of sticking up in space, right? So you get these pi bonds kind of like, looks like this. They look like this. So you get this up top, and in the bottom, you have this resonance, okay? And if I use this as a functional group, I take one of the hydrogens off and use that as a functional group. It's a, what? What's it, how do you say that? An arene, right? An arene, okay? Aromatic. Aromatic, something's aromatic. Point of aromaticity. Okay? This is aromatic. It means it's aromatic. Not like aromatic, a great fragrance. You know, a lot of those fragrances are esters and things. But, you get it? Yeah. Okay. Enough said. We went over the functional groups. How we do, all right? So we'll call this functional groups, okay?